In separation of a mixture experiment, we start by building our setup. Start by clamping your separatory funnel holder into your stand. Make sure everything you clamp in these setups are tight. Put your support on top of your separatory funnel holder and then put your separatory funnel in to make sure it holds it properly. Make sure you arrange your holder at a height that you're comfortable working with. Don't forget the handle of the stopcock is positioned parallel to the ground rather than vertically when it's closed. Make sure your separatory funnel is closed and the back side of the stopcock is also tight before you pour any liquid into your separatory funnel. Then make sure you have the stopper on your separatory funnel as well. Start by adding your solvent, 10 milliliters of diethyl ether, into your separatory funnel measured by a graduated cylinder. Make sure to put the stopper back so that the solvent does not evaporate. Then you go to get your solid mixture. And then add your solid mixture into your separatory funnel with the diethyl ether in it. After you add your mixture into the ethyl ether, put the stopper back on and gently mix the solid mixture in the solvent. Make sure to open the cap for a few seconds to release any gas formation inside the glassware. Next, cautiously add 10 milliliters of saturated aqueous sodium bicarbonate solution to your separatory funnel. After this step, take your separatory funnel out of the holder and shake it in your hand. Make sure you're supporting the stopper and the stopcock with both of your hands when you're shaking. After your first short shake, make sure to release any gas that is evolved inside the glassware. Make sure you do this gas release step before you shake it too much, since initially gas formation will be excessive. Make sure to repeat this shaking and releasing gas step a few times until you stop hearing the gas release when you open the stopcock. After you stop hearing the gas release sound, put your separatory funnel back into the holder and take off the stopper at the top and let it sit there for a few minutes to see the separation of two layers. Once you see the two layers of liquid clearly in your separatory funnel, start separation of your two layers. You will start this by putting a beaker below your separatory funnel and slowly start opening the stopcock. Make sure you're not opening it too fast, as this will lead to collecting both of the layers instantly. At first, you are only trying to collect the bottom layer. Stop releasing the liquid once you see the layer separation line disappear. After you collected the first bottom layer, you are going to add 10 more milliliters of aqueous sodium bicarbonate into the top layer that is left in your separatory funnel, and then shake and release gas again like you have done in the first step. This will ensure you have collected all of the salicylic acid, which will be dissolved only in the aqueous layer in your mixture. Again, wait until you see 2 layers clearly, and then take off the stopper at the top before you start collecting your bottom layer. Make sure you always take off the top stopper before you start collecting, because you need atmospheric pressure for the liquid to start dripping out of your separatory funnel. Make sure that you have labeled your beakers that you're collecting your layers into as water and ether layer, so that you do not mix them up for the next steps of the experiment. Once you have collected both your top and bottom layer into separate beakers, you can start the next steps. Start by acidifying your water layer that has salicylic acid in it by 6 molar HCl, which is concentrated hydrochloric acid. Once you start acidifying, you will start to see vigorous bubbling and formation of white precipitants in your beaker. Try to put as little acid as possible in this step. For this, you will want to add a little bit of acid and wait a little bit to see if the vigorous bubbling subsides. While you're performing this step for the water layer, make sure you have covered the top of the beaker that you have your ether layer in, so as not to let the ether evaporate. Once you have finished acidifying your bottom water layer that has salicylic acid in it, you will want to separate your solid from your liquid part with vacuum filtration. In order to do vacuum filtration, you will have to build your setup first. For this setup, you will be using one of the red hoses that are hard and will not break under vacuum. Make sure to connect your red hose to one of the yellow outlets that says vacuum on its knob. You will be using a flask that has an outlet for this hose for vacuum filtration, and you will have to make sure that you clamp this flask to a stand so that it does not flip over during vacuuming. Make sure to put one of the rubber supports between your flask and your funnel. Put one of the small filters into your funnel and make sure it sits well with the help of a spatula. Make sure the funnel sits at the mouth of the flask properly, and make sure to test your vacuum before you start filtering anything. When you start filtering, start pouring your acidified bottom layer slowly into the funnel to not overfill the flask at the bottom. If the flask at the bottom fills up to the point where it's connected to the hose, make sure to empty it before you pour anything else into the flask. If you would like to wash more solid from the beaker, you can use the liquid in the flask that is filtered out of your solid to rewash your beaker and filter any remaining solids that are in the beaker. You may repeat this step as much as necessary. Then take out your filter that has your salicylic acid and put it in a beaker and leave it for drying until the next lab session. Make sure that you have pre-weighed your filter paper and your funnel before you have started filtering your salicylic acid. Along with your salicylic acid, leave the beaker that contains ether and naphthalene in it with open mouth under your hood until the next lab session. For the sublimation step, before you start this step, make sure to determine the weight and melting point of your crude naphthalene. After this, scrape off the naphthalene from the walls and bottom of your beaker with the help of a spatula into a 25 ml filter flask. Make sure that you have turned on your heater beforehand so that it will heat up to the temperature that you want it to and stabilize it there. With the help of a neoprene adapter, like in the previous vacuum filtration setup, suspend a centrifuge tube filled with ice over the solid in the flask. This will be your cold finger. Make sure that you have rested this cold finger in the ice bath with ice filled in it for a while before you adapt it into your filter flask. Make sure to wrap 1 or 2 Kim wipes around the top of the neoprene adapter to catch any condensation that will take place on the outside of the centrifuge tube. During the sublimation step, you can refill this with ice as much as necessary. Make sure the temperature setting is at a gentle setting, meaning that it is not too hot. It can be around 70 to 85 degrees. During the sublimation process, you will start to see crystals forming on the cold finger as well as on the walls of the filter flask a little bit. You would expect to see more of the crystals forming on the cold finger rather than the walls of the flask. Once you see the cold finger covered with crystals, you can take it out of your filter flask to scrape the crystals on the surface of the cold finger into a vial with the help of a spatula. If you have a lot of your naphthalene left at the bottom of your filter flask, you can put the cold finger back on your filter flask and continue the sublimation process for a little while longer to collect more of your naphthalene in the pure form. For the purification of salicylic acid, you will be performing recrystallization. For this, you will have to first determine the weight and melting point of your crude salicylic acid. For recrystallization, you have to heat up your solvent to its boiling point, which is distilled water in our case. You would want to use as little as possible from your solvent to dissolve your salicylic acid. Start by adding a little bit of your boiling water into your salicylic acid and try to see if this dissolves your solid salicylic acid. If during the addition of your boiling solvent into your solid you are not able to dissolve all of your solid, you may put the beaker that has your salicylic acid on the heater for a few minutes to gently heat it further. Once your solid is completely dissolved, leave it to cool to room temperature on the bench top. After it is cooled to room temperature, you will be putting it in an ice bath to cool it further. During this cooling period, you will start to see crystals forming. Once your crystals are formed, you will collect the crystals by vacuum filtration. The filtration setup is the same as before. Make sure to clamp the filtration flask to a stand so that it does not flip over during filtration. After you have vacuum filtered your solid, let air run through it for at least a couple of minutes to dry it further. Once both your pure naphthalene and pure salicylic acid are dried, you may continue to determine their weight and melting points. For melting point, we are using capillary tubes. These capillary tubes are different from the capillary tubes that are used in TLC. They are longer, thicker and one end of them is closed. You will want to press the open end of the capillary tube into your solid sample to get some of the solid inside the tube. Once you get some of the solid into the open end of your capillary tube, you will want to pack your solid at the bottom of your capillary tube. To pack your solid at the bottom of your capillary tube, you will be using a larger tube with two open ends. You will release your capillary tube from the top of this larger tube to the end of this larger tube to pack your solid at the bottom of your capillary tube. Once you're done packing all of your samples into capillary tubes, you will be placing them into the melting point apparatus. Once you place them into the empty spots in the melting point apparatus, you can turn it on and start running it. Once started, melting point apparatus will slowly increase the temperature and you will determine the point at which a sample starts melting and at which the sample is completely melted. Your melting point will be this range. The experimental melting point that you will be giving in your data will be a range. It will not be a single melting point.